Good morning to everyone. I am Dr. Sumi MS. The name of the course is Satellite Communication and today's lecture topic is Geostationary and Non-Geostationary Orbits. On completion, the students will be able to understand about geostationary and non-geostationary orbits, explain about geostationary satellites and their coverage, and also list the different types of non-geostationary satellites. Geostationary orbit. A geostationary orbit is one in which a satellite orbits the Earth at exactly the same speed as that of the Earth's rotation and at the same latitude, specifically 0, which is the latitude of the equator. A satellite orbiting in a geostationary orbit appears to be hanging in the same spot in the sky and is directly over the same patch of ground at all times to the visible from the ground. A geosynchronous orbit is one in which the satellite is synchronized with the Earth's rotation, but the orbit is tilted with respect to the plane of the equator. A satellite in a geosynchronous orbit will wander up and down in latitude, although it will stay over the same line of longitude. Geostationary objects in orbit must be at a certain distance above the Earth. If it is very much closer to the Earth, then the orbit will decay due to the Earth's gravity, and if it is very much farther away from the Earth also, it will escape the gravity altogether. Hence, these objects are positioned at a distance of about 35,786 kilometers from the surface. The first geostationary satellite was orbited in 1963. Following that, we have the first geostationary one. What is a geostationary satellite? A geostationary satellite is an Earth orbiting satellite that is placed at an altitude of approximately 22,300 miles, that is 35,800 kilometers directly above the equator. These satellites revolve in the same direction of the Earth's rotation, that is from west to east. The term geostationary comes from the fact that the satellite appears nearly stationary in the sky to a observer from the ground. These satellites complete one orbit in about 24 hours, which is the same amount of time taken by Earth to complete one rotation around its axis. The satellite appears to be stationary from the perspective of someone at the ground and as it moves in synchronization with the Earth's rotation. Geostationary satellites are equipped with transponders that can receive, amplify and retransmit radio signals to and from the Earth. These signals can be used for a wide range of applications such as telecommunications, broadcasting, remote sensing and navigation. How do geostationary satellites work? A geostationary satellite maintains its position in space relative to the Earth's rotation using thrusters and reaction wheels. These tools help the satellite make small adjustments to its position whenever needed in order to keep it in track in its orbit at the same speed as that of the Earth's rotation and also remain in the same position above the Earth's equator. A satellite can achieve a 24-hour orbit only at a 22,300 mile altitude. This orbit keeps the geostationary satellite fixed or stationary over one longitude at the equator. Coverage of geostationary satellites. A single geostationary satellite has a line of sight covering about 1/3 of the Earth's surface. That is, it can see a third of the Earth's surface wherever it is positioned along the equator. So, as a whole, we require 3 geo satellites to cover the Earth. The satellite's orbit usually provides coverage from 20° north latitude to 20° south latitude, and 3 such satellites that are separated by 120 degrees of longitude can provide coverage of the entire planet, with exception from some circular regions at the north and south poles, which can be addressed by polar satellites. Non-geostationary orbit. A non-geostationary orbit refers to a type of orbit used by satellites in which the satellite is not stationary relative to the surface of the Earth. Instead, it orbits the Earth at a lower altitude than geostationary satellites and completes an orbit in a much shorter period of time. non-geostationary satellites. These satellites occupy a range of orbital positions, and we have low Earth orbit satellites as well as medium Earth orbit satellites. Low Earth orbit LEO satellites are located between 700 km to 1500 km from the Earth, and medium Earth orbit satellites are located at about 10,000 km from the Earth. They do not maintain a stationary position but instead move in relation to the Earth's surface. Types of non-geostationary satellites are little low Earth orbit satellites, big low Earth orbit satellites as well as medium Earth orbit satellites. A little LEO is a small non-geostationary satellite which operates in low Earth orbit, providing mainly mobile data services. And a big LEO is a larger non-geostationary satellite operating in the low Earth orbit, and they provide mobile telephony services. Many of the new proposed global mobile phone services are provided by such type of satellite. A medium Earth orbit satellite is a non-geostationary satellite which is operating in the medium Earth orbit and also providing mobile telephony services. These satellites have also been proposed to be used as a part of the new global mobile telephone systems. The most prominent satellites in the medium Earth orbit are the satellites which comprise the global positioning system. The GPS was developed by the US military and was also later opened for civilian use. It is used today to track planes, ships, trains, cars or anything else that moves. Anyone can buy a receiver and track their exact location by using the GPS receiver. These satellites are traveling around the Earth at speeds of about 7,000 miles per hour. GPS satellites are powered by solar energy, and also they have backup batteries on board to keep them running when there is no solar power. Small rocket boosters on each satellite keep them flying in the correct path. The satellites have a lifetime of about 10 years until all their fuel runs out. The GPS satellites orbit at a height of about 19,300 km and orbit the Earth once every 12 hours. Quiz questions on geostationary and non-geostationary orbit. What do you mean by geostationary orbit? What is a geostationary satellite? How do geostationary satellites work? What are non-geostationary satellites? Give a note on global positioning system. Thank you.